what we're going to do in this video is get a little bit more practice constructing Lewis diagrams. And in particular, we're going to try to construct the Lewis diagram for formaldehyde. Formaldehyde has one carbon, two hydrogens, and an oxygen, CH₂O. So pause this video and have a go at it. Try to construct a valid Lewis structure or Lewis diagram for formaldehyde. All right, now let's do this together. Now the first step, and we saw this in a previous video, we want to think about all of the valence electrons for this molecule. So we want to account for valence electrons. Now the reason why we want to do that is so that while we're trying to create this structure, we are making use of all of the valence electrons. And to figure out how many total valence electrons we have, we can look at a periodic table of elements. We can see that carbon, it's in that second row in that second period, so its second shell is its outer shell. And in that shell, it has 4 valence electrons. So carbon has 4 valence electrons. A neutral free hydrogen atom is going to have 1 valence electron, but we have 2 of them here, so it's going to be 2 times 1. And then oxygen, it also is in the second period, and in its second shell, it has 6 valence electrons. And so the total valence electrons in this molecule are going to be 4 plus 2, which is 6, plus 6, which is equal to 12 valence electrons. Now, the next step is to try to draw a structure. Try to draw single bonds, I'll say. Single bonds. And a key question is, what do we think is going to be our central atom? And the rule of thumb is the least electronegative atom that is not hydrogen is a good candidate for our central atom. So we can rule out hydrogen. So between carbon and oxygen, we know that oxygen is one of the most electronegative atoms, one of the most electronegative elements on the periodic table of elements. It's very close to fluorine. And so carbon is a good candidate for the central atom. So let's put the carbon right over here. And then let's put these other atoms around it. We could call them terminal atoms. So let's put our oxygen right over there. And then we have 2 hydrogens, a hydrogen there, a hydrogen there. And let me draw the bonds. So that's a single bond. That accounts for 2 valence electrons. That accounts for 2 valence electrons. That accounts for 2 valence electrons. So I've just used 2, 4, 6 valence electrons. So if I subtract 6 valence electrons, I am now left with 6 valence electrons. 6 valence electrons. So the next step is allocate the remaining valence electrons, trying to get to the octet rule for atoms that are not hydrogen, and then for hydrogen, trying to get it to have 2 valence electrons. So allocate remaining valence electrons. All right, so let's start with this oxygen. This oxygen already has these 2 electrons that it's sharing hanging around. So in order to get to the octet rule, it needs 6 more. So let's give it 6 electrons. So 1, 2, 3, 4, 5, 6. Well, I've just used up the remaining 6 valence electrons. So I don't really have any more to play with. But let's see how the other atoms are feeling. So hydrogen here, it's able to share these 2 electrons that are in this covalent bond. So it's feeling good. It can kind of pretend that it has a full outer shell, because its outer shell is just that first shell that's filled with 2 electrons. Same thing for this other hydrogen. So at least the terminal atoms, the oxygen and the 2 hydrogens, are feeling like they have a full outer shell. But in the fourth step, we're going to look at our central atom. So let's focus on the central atom. And do we need more bonds, or do we need to do something interesting here? And what we see is that carbon, it's able to have 2, 4, 6 electrons hanging around it, but it would love to have 8. Carbon would love to have a full outer shell. So how could we do that? Well, we could add more bonds. Where could the bonds come from? Well, it would come from some lone pair of electrons. Well, the only lone pairs of electrons are hanging around this oxygen. So what if we were to take, say, this lone pair of electrons and then construct another covalent bond with that? Then our Lewis diagram will look like this. I will actually redraw it. So you have your carbon, you have your 3 original covalent bonds. You had a hydrogen, and then you had your oxygen right over here. And now we formed a new covalent bond, just like this. And then you have these 2 other lone pairs around the oxygen. So let me draw that. So 2, and then another 2 around the oxygen. And this is looking pretty good because the oxygen, it still has 8 electrons hanging around, 4 in lone pairs, and then 4 in this double bond that it is sharing. The hydrogens still have 2 electrons hanging around. They're able to share the electrons in each of these covalent bonds. And now the carbon is participating in, you could think of it as 4 covalent bonds, 2 single bonds and 1 double bond. So each of those have 2 electrons associated with it. So it has 8 electrons hanging around. So this is looking really good as a legitimate Lewis structure or Lewis diagram for formaldehyde.